Respected Dr. Radhakrishnan, Dr. Shailesh Nayak, friends, respected delegates. In our country, we have had a very deep interest in mathematics, astronomy, and science in general. In the last century, there was spectacular growth in the scientific research. The International Geophysical Year, IGY 1957-58, being observed to study the peak solar activity, saw the launch of Sputnik, the first artificial satellite of the Earth. By that time, large number of scientific institutions such as Tata Institute of Fundamental Research in Mumbai, National Physical Laboratory in Delhi, Physical Research Laboratory in Ahmedabad, and many universities had participated in the research work. And this is the one that really set the space. This was recognized by Dr. Vikram Sarabhi as an opportunity for international collaboration for conducting experiments there by establishing an international rocket launching station. But that also meant that we need to follow up by our own rockets instead of borrowing the rockets from outside. It is now more than 51 years since we started our modest efforts. In the last 10 years or so, we have now developed the required technology in a self-reliant manner. We are all benefiting by the applications of the technology in our day-to-day life. The year 2014 was exceptionally good year for our space efforts. It started with the successful launch of the GSLV with the indigenous cryogenic upper stage. We have had very good successes in the launching of the satellites for communications and navigation. We had a successful launch of a satellite for France. And to top it all, we had a successful insertion of our satellite in the orbit of Mars. This spacecraft was launched on 5th November 2013, and it was inserted in orbit around the Mars on 24th September 2014. Last month, we also had a very successful suborbital flight of the LV-M3, the heavy lift launch vehicle. In the light of this, it is really fitting that this plenary session on the Mars mission has been organized here today at the 102nd Indian Science Congress, organized by with the theme of Science and Technology for Human Development. Obviously, there will be many questions in the minds of various people, scientists, and it is really very fortunate and fitting that Dr. R. Radhakrishnan, Chairman, Indian Space Research Organization, is here and he has agreed to have this as an interactive session. Let me ask some few questions to start with. What were the major technological challenges for Mars orbiter mission? What are technology spin-offs and managerial lessons learned from our Mars orbiter mission?
Thank you, sir. In fact, when we talk about the Mars, the neighbor of Earth, distance is the first challenge for us. When we talk about Moon, where we did an excellent work in the year 2008, the distance was 400,000 kilometers from Earth. That means 4 lakh kilometers. We were still in the sphere of influence of Earth. But here, we talk about a distance of nearly 55 million kilometers when Mars is closest to Earth and 400 million kilometers when it is farthest. There are specific opportunities based on the geometry of Sun, Earth, and Mars when we can have this mission. The third part of it is we don't go there straight. We go through a circuitous path, a path around the Sun called a heliocentric orbit, and the distance to be traveled along that arc is nearly 660 million kilometers. This is translated into two aspects. One is the communication delay for a signal to reach the spacecraft, or for us to understand what is the health of the spacecraft and take corrective action on the ground. It could take 20 minutes, sometimes much more than that. So first requirement is the spacecraft must have an autonomy to take decisions on itself by looking at the health of the systems. So that was the first challenge. The second challenge was when you go for orbiting precisely around Mars, it talks about how do we start from here. When we leave this sphere of influence of Earth and move towards Mars, we have to follow an arc in such a way that on arrival near Mars, it is at that distance of, in our case, 500 kilometers plus minus 50. And one has to estimate what are the influences of all other planets and sun on this spacecraft during this period. So it was a challenge for technologists, a challenge for our mathematics people. Today we talked about mathematicians. This is one mission in which people respected mathematicians.
Okay, that is really something. My second question was, what are the managerial lessons that we learned from this mission?
One more thing you asked, what are the technological spin-offs? If we have the autonomy built into this spacecraft, the same thing could be adapted for the navigation satellites or remote sensing satellites or communication satellites. And what is the advantage? If you put this smartness in a remote sensing satellite, and the satellite is going around the Earth looking at the forest of India, satellite itself will take decision where it has to look more frequently based on the afforestation, deforestation activities taking up. Or it can be more efficient, can have more life. Operations becomes better.
Okay. And the managerial lessons, particularly?
Here the issue was, the time was the essence of this mission. As I said, we had to do it in November 2013 for the launch from Earth. And we missed that, we had to wait for another 26 months. We decided we will try this first opportunity. So from concept to fruition, we had to do this in 4 years and 2 months. And the spacecraft had to be ready, fully tested for this environment within 18 months. That is the most important challenge. The second was, if you look at the US experience, they went with a rocket which was having 10 times more capacity or power. We had to manage a mission using our own PSLV. It was a complex mission. So that was second challenge for the management.
You said that there are limited opportunities. Are these limited opportunities coming up because we want to utilize the minimum energy kind of a trajectory?
Exactly, that is the basic objective, and Mars is going around in a different orbit and the spacecraft goes, so you have to capture that. That's the basic geometry of the planetary system, and we have to respect that.
After the successful insertion of the Mars orbiter spacecraft in the orbit around Mars, how is the spacecraft functioning in orbit now?
It is doing excellently well. And first and foremost, the primary objective of this mission was demonstrating the capability of India to orbit a spacecraft around Mars. That has been achieved. And during this course, we did not have any failure in any of the subsystems of the spacecraft. Now, the next question is how much useful life is there and what the 5 instruments on board could do. Our pessimistic or conservative estimate was we could have a life of 6 months. Now, we have already completed 100 days successfully. We have fuel. We have no concern on the availability of the fuel for controlling the spacecraft. And the systems are working well. There is one event going to take place in June 2015 because of a geometry of Sun, Earth and the spacecraft. For 15 days, we would not have communication from Earth. Okay. So during those 15 days, the spacecraft has to manage by itself. That's a real test for the autonomy provided into the spacecraft. Once you are able to overcome that and successfully come out of it, then I think we will have a few years of life.
Is this because of the Earth, Sun, Mars, all of them coming in the same line?
The Earth and the spacecraft and Sun coming in the line. Now there are 5 instruments. One is the Mars color camera, which is just giving the picture of Mars. And we have been seeing that. The second and most important thing is a theme for scientific investigation, that is availability of methane, and if so, what is the source of methane?
Okay.
There are 2 instruments and they are making the observation. And the other theme is on the exosphere related to the hydrogen deuterium, and they are also making observations. And the scientific community will be looking at what are the findings, and they will come out soon. One more thing I just wanted to mention: October 19th in 2014, there was an encounter with a comet. And all those spacecrafts that were around Mars did tweaking of its orbit to ensure that when the comet passes by, we are on the other side of Mars. And that we did successfully. The spacecraft did also take some measurements during that period.
Did it require us to take out or use some fuel for that one?
Just a minor tweaking, and we had used less than 1 kilogram of fuel for that purpose.
Good.
What we did was, the apoapsis of the spacecraft was around 77,000 kilometers. We brought it down to 72,000 kilometers, closer to Mars. In the process, the period for the orbit also came down. Okay. So exactly during those 20 minutes of the comet passing by, we were on the other side of Mars. This is what.
I would like to really thank you for the time that you have taken, your answers. Would you like to say certain few things, and then we'll close the session?
I just want to say, when we talk about the Indian space program where we are, there is an organization in USA called Futron that benchmarks the 15 spacefaring nations on a matrix of 50 parameters, qualitative, quantitative. India has been there as one of the 6, mostly 5th, 6th position for the last few years. Number 2, quantitatively, the Japanese Science and Technology Institute has evaluated all this, and there too we are. But in terms of space applications, India is the role model. When we look at the planetary exploration for the Mars, we are the first country who did successfully on the first occasion. So this is something creditable. If you look at the launch vehicles of India, the PSLV has launched 40 foreign satellites, and a few more are in the pipeline. So 2 satellites were built by India along with a strategic partner for European customers. So there we stand in terms of the current state of technology. We are moving towards a technology to be state-of-art in communication technology, to have 1 meter technology for remote sensing to be enhanced to 0.25 meter technology, microwave remote sensing in several other frequency bands, and also we are looking at the navigation satellite to be improved further for various applications. So this is our general direction.
Thank you very much.